we isolated each of the resolvins and determined their structures, and found that they stimulate resolution of inflammation in animal models, animal disease models, and reduce pain. SPM active, as you might know, is the natural preparation of the SPM precursors isolated from Peruvian oils of marine origin. So they are pretty effective in being converted in humans, much more so than EPA or DHA, the ultimate precursors. So they do what they're touted to do. They resolve inflammation, they shorten the recovery time, and they reduce pain. So all scenarios where the innate immune inflammation resolution program is evoked, which is almost in all of the conditions today seen in the Western world, SPM active has a role. I like the Metagenics and the way that they promote SPM active, because my roots are in structure-based drug design. My true goal is to reduce pain and suffering in as many people as possible. And my hope for the SPMs was that each of them would become a drug targeted for a specific disease, from eyes and inflammation in the neural systems from head to toe. And that's a long haul for an academic lab. So when Metagenics made the thrust to move towards supplement, I thought that this was ideal, because it's ultimately getting it to humans is where we want to be. And getting those clinical trials in humans and evidence in humans is so important. And in the hands of clinicians, then we'll really know the power of those molecules as physicians learn to use them in different conditions. The only other one that is exactly identical to SPM active is the Liponova. And they are basically the same formulation. They're produced by the same company. There's no other formulation that comes close. There are many companies that claim that they have SPMs. When I go online now and I look, there are like 20 different companies. And in some sense, that makes me feel good, because that's the highest form of flattery, when people copy you and where you're going and see your vision. And as long as there's fact behind their label, I'm happy to give it a try. It's really pretty simple. You know, think of it like the body's defense from bacterial invasion is the innate immune system. We have these white blood cells that could smell bacteria when they enter. They move to capture them and phagocytize them. But sometimes they swarm like sharks moving along for red blood cells. They can smell, and they swarm so much that they cause collateral tissue damage. So in war, in host defense, us against the microbes, there's collateral tissue damage, and that starts an inflammatory response that the SPMs are like little robots and little traffic controllers to calm down those cells, prevent the swarming and congregation and collateral tissue damage, but they help. Today's pharmacopoeia for anti-inflammatories eventually become immunosuppressive. This is a problem because then you become open for other infections, and the SPMs actually reduce the collateral tissue damage, and they boost up the white blood cells' ability to eat and kill bacteria. They also have this incredible function of clearing debris and stimulating the clearance of debris. So they are like little robots. They are directing the traffic and keeping it organized. We have a new NIH grant on looking at the role of resolvins and the other SPMs in controlling inflammation and reducing cancer burden. And I'm very excited about this, and it's work that I've been carrying out with a cancer colleague of mine, Dr. Deepak Panigrahi. And now that we have a new RO1, you'll see some exciting results, because at least in the animal models, the tumors shrink. It was so unexpected and so gratifying, because around all solid tumors, it's well known that there's a rim of inflammation and collateral tissue disruption of the matrix. So I'm very hopeful there that we can help those individuals. We also got another NIH grant with my colleague Bruce Levy, who's the chief of medicine now. He's a former member of my group and program project grant. And we're looking at how environmental exposures stimulate inflammation and collapse the body's resolution response, and how can we correct that with the SPMs. So keep tuned, because there's some exciting results coming up there. Try and think of it as the difference between cholesterol and testosterone, which is formed from cholesterol by the body, and estrogen. They have very, very different functions, and you have to have the right amount of precursor, cholesterol, to keep everything in balance, right? So the essential fatty acids are essential because it was discovered back in the 1920s that they were important to wellness. EPA is 20 carbons long, 5 unsaturated double bonds, and it is converted by the vasculature and the innate immune system, those white blood cells, to E series, E for eicosapentaenoic acid, resolvins. Why resolvins? Because they resolve inflammation. And that was our first hint of what those molecules were doing when we determined the structures. The D series resolvins also are produced initially by the vasculature and then the white blood cells, and then the reparative macrophage produces it on its own. I'm my own subject on that one. I take the precursors, I take omega-3s, and take SPMs as well. Why? Because what we learned in the laboratory is that a small amount of SPMs stimulates a feed-forward response to get back to homeostasis, and they stimulate the conversion and more production of pro-resolving mediators from EPA and DHA. So if you want to get the full benefit of the SPMs, put a little gas in that Formula One. These are specific molecules, EPA and DHA, and the fish oils in many, the different preparations of them over the counter that people can purchase, and they're not all equivalent. And there's a lot of different molecules in there depending on how a company prepares and isolates the EPA and DHA from marine oils. So why are they essential? Because our body doesn't make EPA and DHA. We have evolved along with the marine organisms to eat fish, and they are, to draw an analogy, they are like vitamins. We need them. They are essential to life. And I really came to that conclusion by doing two different experiments. First, we looked at human breast milk. And of course, there are resolvins and SPMs in human breast milk. They are highly conserved, and nature has preserved them in that most vital, what we feed the newborn. I've been interested in model organisms for a long time, and it turns out that fish, just like the anchovies, produce large amounts of SPMs, and they produce it in the equivalent of human bone marrow. In the fish, it's called the head kidney gland. It is the hematopoietic organ, meaning that that's where the fish's blood cells are born. And there are high levels of resolvins in fish head kidney glands. There was one very exciting study came out just a couple of weeks ago from a group in Norway, found that salmon, head kidney gland, salmon marrow have microgram amounts of D-series resolvins. Now, why is that? Why has evolution placed those molecules, those same molecules that we make, in that important organ in the salmon? The authors had some evidence that their production was under circadian control and helped the immune system in the salmon. How nice. Learning from nature is our job, and that's all we're doing, and trying to put it to use for reducing pain and suffering, and in helping as many people as we can. That's our mantra in my research group. It always has been. So I'm very happy that Metagenics took up the charge. And just for full disclosure, I don't have any financial conflict of interest. I don't get anything from Metagenics. So I'm really honored to have Metagenics in the game. Oh, this is a loaded question, but it is so important, so I will jump up and down soon. No. The NSAIDs, the non-steroidal anti-inflammatory drugs that you can buy over the counter, were all designed to look like the shape of aspirin, starting in the 1950s. One of my mentors discovered that aspirin, Bengt Samuelsson at the Karolinska Institute in Stockholm, 1982 Nobel laureate in physiology and medicine. He discovered that aspirin blocks prostaglandin production. And all of a sudden, people started to say, industry primarily, oh, the prostaglandins are bad guys. Well, they're very important in mounting an acute inflammatory response. And I want to remind you that, and those that are watching, that the acute inflammatory response is protective. It is vital. What we address is excessive inflammation, when it's uncontrolled. The prostaglandins, when they are made early on an inflammatory insult, they stimulate the production of the enzymes needed to produce SPMs. When you take an NSAID, you disrupt resolution. They are deleterious in the long run. They eventually become immunosuppressive, and they hurt the mucosal lining, and that's well appreciated. So, what more can I say? We have to stop using those drugs. They were designed in the 50s. There was a new round of them that came out in the 80s, the COX-2 inhibitors, and unfortunately, they haven't lived up to, they've been detrimental. That's all I'll say. There are still some out there that are pretty good, they're safer, and they work tremendously well in pain reduction, because prostacyclin, which is made by the vascular endothelium, was shown by Shu Nuramiya in Japan to be very important in pain nociception. So you're actually blocking the prostaglandin that's signaling in pain. And for most people, that makes them feel much better. But at the tissue level, there's still collateral damage and destruction being done. SPMs control pain, and they're very effective, very potent, demonstrated by many, many groups around the world now. And it's not as simple as arachidonic acid is pro-inflammatory and EPA and DH are anti-inflammatory. No way. There's a lot of individual cell traffic going on. And it's all about when and where in the local environment, local milieu that counts. So we've focused on pus, and we want to control excessive pus. And that's where we first discovered the SPMs. You have to remember, in all those, when you went to medical school, remember your coag from hematology, because the coagulation system is protective. It's when it's in excess, you get excessive platelet aggregation, clumps and clots and occlusion of vessels. This is when it's an issue. So we need to get back to basics on the single cell level